Hi students, welcome to today's class. So last few days onwards we are we are learning the concept of limits. So various methods, various formulas we are discussed. So in this video I am going to explain a very easy and important tool to find the limits of a function very easily. Okay, now so almost we can call it as a short trick method. Okay, so what is that limit of the function using this method is? So the method is called L'Hopital rule. L'Hopital rule, S is a silent. L'Hopital rule. What is this L'Hopital rule? Let us see this. First let us take a function. So find out the limit extends to 0 of this function as x value approaches to 0. Let us see the behavior of this function. So as x value approaches to 0, let us substitute wherever x is there, substitute 0. So here what we will get 16 to the power of 1 by 4. This is a 2 to the power of 4, 2 will cancel. So 2 minus 2 we will get 0. Numerator we are getting 0. Coming to the denominator, as x tends to 0, 5 into 0, 0. 32 plus 0, 0. 32 means what? 2 to the power of 5. 5 cancel. 2 minus 2, 0. Okay now. So here we are getting 0 by 0. First of all, you have to know one thing is 0 by 0 is not a finite value. It is not a finite value. It is called indeterminate value. Indeterminate value. That means we cannot determine, we cannot estimate, we cannot evaluate the value of 0 by 0. Understand? Don't think that we can cancel 0 cancel 1 is the answer. Don't, it is not the correct way. Okay now. So then how to answer, how to proceed, what is the answer for this problem? So can we throw this problem in a dustbin, so therefore the answer is not correct? So it is not like that. Okay now. So then how to solve this problem using L'Hopital rule? What is L'Hopital rule? Let us see that. Welcome to this L'Hopital rule. So for define L'Hopital rule, let us take two functions f of x and g of x. F of x and g of x be two differentiable functions. Differentiable functions in an open interval I. In an open interval I. Let two f of x and g of x be two differential functions in an open interval I, and probably they are not differentiable at x is equal to a belongs to I. So let us take that there is a one point where it does not differentiable at x is equal to I. Okay now, right. Now let us suppose that let limit extends to c, f of x is equal to limit extends to c, g of x is equal to c. Probably at x is not equal to a, x is equal to c, and the limit extends to this is equal to 0. Let us say that as x value approaches to 0, f of x value limit extends to 0, c, g of x value is also 0. Now limit extends to c, f of x by g of x value, how much we will get? We will get 0 by 0. It is same as limit extends to c, f dash of x by g dash of x, he is saying. So okay, it is a differentiable, continuous differentiable function. So limit extends to c, f of x, g of x, if you get this 0 by 0 form, or plus or minus infinity, plus or minus infinity. See here, this form can be defined as limit extends to 0 f of x by g of x, whether you will get 0 by 0 or infinity by infinity or minus infinity by minus infinity, 0 by 0 or infinity by infinity or minus infinity by infinity, then it is defined as limit extends to 0 f dash of x by g dash of x. Again we will get a one doubt, sir, this value is also if you are get this same format, that is 0 by 0, infinity by infinity, minus infinity by minus infinity. Again we have to differentiate this f double dash of x by g double dash of x until we get a finite value. Until we get a finite value. Finite value means what? Any real number, root 2, root 3, 1 by 2, 1 by 7, 7 by 8, like that. We have to continue the same process. Okay, now. So this is the rule called L'Hopital rule. Sir, how is this possible? How is this possible? Is there any proof is there for this? Yes, it is a theorem. It has a proof. Let us see the proof. Even though it is not important for examination point of view, so if you learn the this concept using proof, so that definitely you will learn this forever. Okay, now. So let us see the proof. Welcome to this concept. So let us see the proof of the L'Hopital rule. So let us take f of x and g of x be two continuously differentiable functions in an open interval I. In an open interval I. Let us f of x and g of x be two continuously differentiable function, means that is an open interval I. Let for a point x is equal to c, let us suppose that f of c is equal to g of c is equal to 0. Let us suppose that f of c is equal to g of c is equal to 0. And also limit extends to c f dash of x and g dash of x exist. That means, of course, it is a continuously differentiable function. Now what we have to prove is, limit extends to c f of x by g of x is equal to limit extends to c f dash of x by g dash of x. This is the thing that we have to prove. Okay, now, right. Right. So let us start with the left hand side is equal to right hand side. So first take the left hand side. Limit extends to c f of x by g of x. Okay, now. Limit extends to c f of x minus 0 by g of x minus 0. Can we take like that? Yes, we can take. See here, f already we suppose that f of c is equal to g of c is equal to 0. In place of 0, can we write like this? So this is equal to limit extends to 0 f of x minus f of c by g of x minus g of c. F of x minus f of c by g of x minus g of c. Okay, now? Right. No problem. Again, we can write it as a limit extends to 0 f of x minus f of c by x minus c divided by limit extends to 0 g of x minus g of c by x minus c. Okay, now? Right. We can write it. Okay, we can. So I multiplied the numerator denominator with x minus c, since x is not equal to c. So x is not equal to c. Sorry, x belongs to here I. C belongs to an number, any number, open interval, it may belongs to, may not belongs to. Okay, right. This is the definition of f dash of c and it is the definition of g dash of c. So the numerator f dash of c, g dash of c. This can be written as limit extends to c f dash of x by g dash of x. Limit extends to c f dash of x by g dash of x, since f of x and g of x both are continuous functions. Okay, now? Right. So I hope that you understand this simple proof. So, but there are, to apply the L'Hopital rule also, there are certain limitations are there. So in everywhere you cannot apply the L'Hopital rule, but there is some problems are there in which L'Hopital rule cannot be applicable. Okay, let us see such type of one problem. Okay, welcome to this problem. Let us see this problem. Limit extends to infinity x minus sin x upon x plus cos x. Okay, now, right. As extends to infinity, clearly infinity minus sin infinity, so this approaches to infinity by infinity we are getting. As we can apply the L'Hopital rule. Okay, so let us apply this limit extends to infinity numerator and denominator differentiate. What is the differentiation of x? 1. What is the derivative of sin x? Cos x by x derivative 1, cos x derivative minus sin x. It cannot be determinant. We cannot find it as x tends to infinity. 1 minus cos x by 1 minus sin x. This value we cannot determine. Then, so here the L'Hospital rule fails. Then how to do this problem, such type of problem? So directly we can do this problem as a limit x tends to infinity. Divide the numerator and denominator with x as x is not equal to 0. X approaches to infinity. So therefore 1 minus sin x by 1 plus cos x by x. As x tends to infinity, sin x by x tends to 0. So therefore 1 minus 0 by this also tends to 0. 1 is the right answer. Understand? So here L'Hospital rule fails. Okay. So let us see some more problems where we can apply L'Hospital rule and we get the solutions very easily. So just by reading the problem, generally students will get a panic over by seeing the problem. They will get afraid, but if you think logically, so if you apply the L'Hospital rule, some problems will be very easy. Let us see such type of problems. Welcome to this problem. Let f of x be a twice differentiable function. That means the derivative exists, second derivative also exists. Function f double dash of 0 is equal to 2. Second derivative at x is equal to 0, its value is 2. Then evaluate this limit of this function. Generally students what they will do, so immediately we will substitute x is equal to 0. Let us see what happens. So this is equal to 2 into f of 0, 3 into f of 0, that is a f of 0 by 0. Understand? So wherever x is they substitute 0, 0, 0. Okay. So 2 times f of 0 plus f of 0, 3 times f of 0, 3 times f of 0 means 0 by 0 we are getting. Okay, now, right. So we have the right to differentiate both the numerator and denominator using L'Hospital rule. Okay. So let us see this. Limit x tends to 0. 2 times f of x derivative is f dash of x minus f of 2x derivative is f dash of 2x derivative. Again 2x derivative is 2. Already 3 is there. We can write down directly 6 times f dash of 2x plus this also f dash of 4x and 4x derivative is 4. So whole divided by x square derivative is 2x. Okay. Now apply x tends to, as x value approaches to 0, wherever x is there substitute 0, 0, 0, 0. So this is a 2 times f of 0, f dash of 0 minus 6 times f dash of 0 plus 4 times f dash of 0 whole divided by 2 into 0, 0. So 2 plus 4, 6, 6 minus 6, 0. Again you are getting 0 by 0. Understand? So next what I have to do, I already explained. So we have to do up to a, you will get a finite value. But definitely for second derivative you will get the answer. Why? Because it is given that twice differentiable. Twice differentiable means definitely for second derivative you will get the answer. Right? Let us see that. Limit x tends to 0, 2 times. This is f double dash of x minus. So f dash of x derivative is f double dash of x, 2x derivative is 2. So this is equal to 12 into f double dash of 2x. This is a 16 into f double dash of 4x whole divided by 2x derivative is 2. Okay now. So as x value approaches to 0, substitute here. So this is equal to 2 times f double dash of 0 minus 12 times f double dash of 0 plus 16 times f double dash of 0 whole divided by 2. Already it is given that f double dash of 0 value is equal to how much? 2. So this value is 2 2s are 4 minus 12 into 2, 24 plus 16 into f double dash of 0 is 2. 16 2s are 32. 32 by 2. So this is equal to 4 plus 32. So 36. 36 minus 24. This is a 2, 1, 12. 12 by 2. So this is equal to 6. 6 is the correct answer. Okay now. So I hope that you understand this solution. Let us see some more problems which you feel by seeing this you will feel so it appears to be very big problem, but the solution is very simple. Okay, now let us see such a type of problem. Hi students, welcome to this problem. See this problem. By seeing this problem where you will immediately general students, they skip this problem, they don't even read the problem also. Okay, so let us read the problem and try to understand, and let us find the solution for this problem. Let f of a is equal to g of a is equal to k. There are two functions are there. At x is equal to a, their functional values are k, and their nth derivative exists and b not equal to sum. So their nth derivative also exists, but it is not equal to n, he is saying. If limit extends to a, f of a into g of x minus f of a minus g of a into f of x plus g of a by f of x minus g of x is equal to 4, then find the value of k. Okay, now so let us see the solution. So here it is given that there is a function. It is a function. It is a very big function. So as extends to a, substitute x is equal to a. Wherever x is a, substitute here. So let us see here, f of a into g of a minus f of a into g of a into f of a plus g of a divided by g of a minus f of a. Let us see what is the value of this. So here clearly f of a into g of a, here minus g of a, f of a, both will get cancelled. It is already given f of a value, g of a value, both are equal. So this is equal to minus k, this is plus k, minus k plus k becomes 0. K minus k, it is also 0, which is a indeterminate form. It is not a finite value, it is not the answer. Then at this time, what we have to approach? We have to take the help of L'Hospital rule. Just like it is an ambulance. So we have to invite the L'Hospital rule. Okay, now so let us invite our L'Hospital rule. Then how to do this? So we have to differentiate both numerator and denominator. So let us see that. Limit extends to a. So this is equal to f of a. So g of x derivative is how much? G dash of x. So this is a g dash of x minus f of a derivative is 0. So minus g of a into f of x derivative is equal to how much? F dash of x. G of a derivative is 0 divided by g of x derivative is g dash of x minus f dash of x. So we find out this everything. Okay, everything is very clear. Now, as x approaches to a, substitute x is equal to a. Let us see what happens. So f of a into g dash of a minus g of a into f dash of a whole divided by g dash of a minus f dash of a. Yes. Wherever x is there, I have substituted. Already it is given that f of a value is k, g of a value is also k. So substitute here k into g dash of a minus k into f dash of a divided by g dash of a minus f dash of a. Okay, now. So here take the k common outside, g dash of a minus f dash of a by g dash of a minus f dash a will get cancelled. We will get the value is k. This k value, so the total this value is equal to k. This is given as 4. Therefore, k is equal to 4 is the final answer. Understand? So by seeing the problem, don't get a panic or afraid. Just to proceed the problem. Wherever this type of problem is there, substitute first x is equal to a, x is equal to b, x is equal to 1, x is equal to substitute wherever x is there in the substitute, then proceed. Automatically we will get the answer. Okay, let us see this type of problem, another one. Welcome to this problem. Evaluate limit extends to 0 tan of log of tan square 2x to the base tan square x, So as apply extends to 0, tan square 2 into 0, 2 into 0, 0. So total this value is 0. Here base value is also 0. So this tan square 2x value approaches to 0, therefore log value approaches to infinity. So as x value approaches to, so see the graph of the logarithmic function, as the x value approaches to 0, the logarithmic function value approaches to infinity. So this is of the form infinity by infinity. Okay now, right, we can apply the L'Hopital rule. So this is equal to limit extends to 0. This can be written as a log of tan square 2x by, this is a log of tan square x. Okay now. Now let us apply the L'Hopital rule. That means find the derivative of both numerator and denominator. So this is equal to limit x tends to 0. Log x derivative 1 by x, that is 1 by tan square 2x into tan square 2x derivative 2 tan x, 2 tan 2x, again tan 2x derivative secant square 2x, again 2x derivative 2 divided by, here also log x derivative 1 by tan square x, again tan square 2 tan x derivative secant square x. Understand? So any more cancellations we will take place here. So here we can cancel 2 we can cancel. This is a tan square 2x, this is tan 2x, this is tan square 2x, 1 tan 2x we can cancel here. Here also tan x, tan square x, we can cancel tan x. Okay now, we can cancel tan x. Now let us see what are the remaining terms we have. Limit x tends to 0. Okay now, so here secant square 2x is there, in the secant square 2x is there. Denominator tan 2x is there, tan 2x is there, divided by, here secant square x is there, secant square x is there, denominator tan x is there. Okay now, of course 2 is also here, 2 is also here. So okay, so let us see here. Limit x tends to 0, 2 into secant square 2x means what? 1 by cos square 2x. Here this is a sin 2x by cos 2x denominator. So here 1 by cos square x into, so here this is equal to sin x by cos x. Okay. So any more cancellations? Yes, we can cancel this as a, okay, cos square x, 1 cos x square x cancel. Okay now. So here also 1 cos x cancel. This cos x sin x will go in the numerator. So this is equal to limit x tends to 0. Already 2 is there. 2 sin x cos x by. This is equal to cos 2x into sin 2x. Okay. Limit x tends to 0. See the numerator. 2 sin x cos x is equal to how much is sin 2x. This sin 2x will get cancelled as x value approaches to 0. 1 by cos 2x value approaches to 1. So 1 is the final answer. Okay now. So very nice problem. This is so very easy problem also. I hope that you enjoyed today's class. With some more problems, tomorrow's class I will stand before you. So until then, all the best.